So we left off here, function templates. If you remember, we have covered, or we have seen function overloading from previous chapters, actually early on chapters when we were doing functions, or chapter that, I think it was chapter 5 or 6 that we covered functions. And function overloading is referred to those functions that they have the same name, but they have different types of like data types. So that means the parameters or the data have different types. So we can actually by using the function templates to overcome that, or replacing the function overloading. It's much better to use these templates. As you will see, we will write the definition of the function one time, and and we can actually call this function with different data, and we can manipulate those data, if they're integers, if they're double, if they're strings. So it's like a generic, like function that you write it one time, and you can, when at the time of compilation or running your code, the compiler knows which one to pass, or like what are the values. So if you remember, this is an example of maybe the swap function that you could write it, passing the parameters as a reference integer, and if you want to be swapping 2 characters, you have to write a separate maybe function definition or declaration for different data types. Now, with the knowledge that we're going to get from templates, you could actually solve this. So you will be writing writing a definition by using a template, which is a keyword template, and inside the angle brackets, or these brackets that you see, you write the class. So these are all like the keywords, but T is just could be called as like a type of data that you're using. So it's going to be later on replacing those different data types that you're going to be passing for this function once you call the function. So for example, as you can see, this T, later on, if I'm passing an integer, that integer is going to be defined as, like it's going to be, put this, instead of T, we will have int. So the data type is going to be defined as an integer if you're passing an integer data type or an argument. And if it's a double, T is going to be replaced with that double. And if it's a character, or if it's, like maybe a string, is going to be exactly the same thing. So that's, one of the very use or reason that we want to be using templates, or, like function templates, is because, they don't, once you write the template, they don't allocate any memory location. And we can actually, once you define them, there is no allocation. And it's, later on when you call them, that's where everything starts, like to, the compiler would be doing its job by just replacing the different data types instead of the T. Okay, so I wanted to show you something, in your textbook, the page that you start the function template is 983. And it's been, there is actually a video that tells you how to write a function template. It's not really that difficult. So this is another example that you can actually square. This function is supposed to be squaring the value or the number that is passed to it as an argument. As you will see, it's going to return that result. But you see that every function will be returning a value, or it could be a void. So if it's not returning anything, you have to specify or specifically mention that it's a void, or use the keyword void. But you see that in this example, we are returning the result, and T is going to be replaced instead of int or double, or whatever that is passed through this function or argument. if I'm passing integer, this t is going to be replaced with an integer. If it's a double, it's going to be replaced with an with that double. So just remember that you're writing a prefix template, which is, that's what for every function that you're writing. If you are, using the function template, this you have to use this. It's kind of like marked with the prefix template, and you have to. It's like a keyword. And then you have the angle brackets or this less than sign or greater than sign, which you are going to be containing. This will be containing one or more maybe data types. It could be generic data types, of course, because you don't see any data types at this point, right? Later on, you see that we can have more than or passing more than one data type. So you could have this with, comma, and you can have class T1, class T2, and they're all separated with commas. And every one of them starts with the class, word class, and followed by the parameter name that will be standing for that data type. Okay, so in this case, we have it as T, but you could name it differently if you want to, but make sure that inside your function, when you are declaring your function, you're going to be using exactly the same thing. And if we had more than one, we have to separate them with comma, and you're going to be repeating that as you go. So this T is for, this is going to be, if I have an integer number, as you can see here, I'm going to, just pass X, and Y is going to be the return type. So you can just put Y is equal to a square X, and then you pass X as like an integer value, which is going to be what is going to be replacing with that T. Okay, so can I do this like for double? Yes, you could do it, and this is what exactly you could do. I mean, if you look at this running, the program for this, look how easy this could be. And instead of like writing overloaded functions, this makes things much easier by just having one time writing the template one time, and inside the main you could just pass integer, which is going to replace this T, or you can have it as double value, which is going to replace again this, and it's going to return those numbers. I have a couple of code here for you guys. If you remember, for swapping, we did have, we could actually swap using, references, or passing the values by reference. And you can, like if I want to be maybe swapping two double or two integer, I have to write these functions two separate ones. I just named them swap values. Very simple program, just demonstrating, how you can write the template for functions. And this is a swap value function. So it's going to swap the content of X and Y. Of course, they're passed as references and or address of those variables. We have to write again the template keyword, and then inside the angle brackets you have the class keyword again, and T is my it's going to be like later on substituted by the different data or data types. This function is void. That means it's returning nothing, right? So that's why I have the keyword void here. The other example you saw, the reason we had T, because that function was returning that data type. Maybe if it was an integer, it would return integer. If it's a double, it would be returning double. This case is a void. It's not returning anything. And, I just came up with, pay attention here that instead of, specifying the data type, you just put T, okay? And you have, like if you're defining any other variable, in the process inside your function. Again, like for example, I want a temporary variable, which is going to be, helping me with the swap, if you remember the algorithm for swapping. So I will define that as T as well, because later on, again, this is going to be replaced with that data type, a specific data type. Like I said, this is a very simple program. In my main, I'm defining 2 integer values and 2 double values, and then I'm going to have the user to enter those 2 values, and then I call the function swap values. See, like x and y, not integers, and for my double, I do exactly the same thing. So I don't have to write this function twice. I can write it one time and call it with different data values. So the result, once you run this code, is going to ask you enter the 2 integer numbers. I'm just going to put 2 integer numbers, and is just like going to be swapping them, and it's asking me to do 2 double numbers. So I'm going to just maybe put 2 more numbers, and this is going to do my swapping as well, and it would return those values and end of the program. Okay, so there are other ones that I want to show you. There are more function templates. This again is another example. Again, this is a type void, but this is an example of having template function with more than one data type. So for example, and you see that I have repeated that with the word class again, the keyword class, followed by the variable, or T1, T2, T3, which later on is going to be replaced with different data types. The same thing for the function declaration. As you see that I have used this T1, T2, T3, and in my main, if you look at this, actually, let me do this as main one, because later on you're going to have an error. Let's go back to function template. Okay, so the main here, I'm calling the function, and look what I'm passing. I'm passing 3 different variables: a string, character, and an integer. And again, the same thing here, right? But it does not matter if I want to just, swap these different data types. Like for example, I have done 2 strings and 1 integer. So this is actually pretty useful, and it's going to be coming handy, in your projects. So the original order is, just the way that you pass them, and then it is going to be reversing the order as well for you. So it's just trying to show how you can manipulate your data using the function template. So the original one that we sent was computer A and 18 is going to go 18A computer. So so you don't have to follow a specific data type order in this case. So whatever you pass is going to be treated that way. So because you're replacing, one is a string, so T1 is going to be considered as a string. I could have had maybe an integer in the beginning of for my first argument that I'm passing through this function. That's the nice thing about it. So let me show you another example of, again, functions here. Function template. This is going to be returning, and it takes 2 different data type. So that's why you see, actually this is 1, but it takes two from the same type. So these both either have to be integer or both have to be a double, because we're trying to return the summing them up and then returning that value. And for this case, we're taking 3 different parameters, so that's why you have to come up with a separate template for that function. So if your function is taking different numbers of arguments, then that means that you have to define and have a different template for that specific purpose. So I'm having, but they can be different data type. It could be double, and then or it could be integers. Either one will work for you. Will work in this case. It doesn't have to be all double. It could be integer, and then it will just add them up. The first one, it says 2, so I'm going to return, enter 2 and press enter. And the next one says 3 variables, 90, and that will return. So I want to show you like how this could be actually integer and it's not going to cause any problem, right? And these actually the ones that I entered was integer already, but just to show you how it works, it's the same thing, right? Okay. Um, uh, Now, let's talk about, and one more thing that I wanted to see, because this might act like a concatenation. It's not going to, because we don't have a string class, probably. Yeah. Let's see if it's going to work, or we have to have a class template for this. No, I think it should work. Yeah. Okay. Okay, so let's do. So see how it gets concatenated? So you could actually, of course I have to change the wording. You could actually use strings as well, because plus or addition for strings works as concatenation. So you put the strings next to each other. Okay, one other thing that I wanted to go over before we go to the templates for classes as well. So it just is just explaining when a function is defined by a template, when it's called, the compiler would be creating the actual definition from a template by, just making sure the types of the parameters from the arguments in the call. So they're matching the types, like the data types that are passed from the arguments, and it's going to be copied into the parameters. So the code makes the compiler instantiate the template with the type integer if it's integer type, in the place of the parameter t. But I told you that there is no actual code generated until there is a call function named, and the function name is called or is being from a main function is being called. So there is no actual code, because the template doesn't even the function template is not even allocating any memory or uses any memory unless is a function call for it. And so when passing a class object to a function template, it will be ensuring that the operators, like referred to in the template, are defined or overloaded in the class definition. So this is just trying to tell you how you have to be making sure that the total number of, maybe arguments are matching. So whatever that you have, all the notes that you have been following, the rules with the functions, it should be exactly the same thing with the function template. So they can be, the templates can be overloaded with, that needs different parameter lists. Just like regular functions, the function templates, it has to be defined before it's been called. And then these two, the first two, it should make sense as well, because we went over them, right? Okay. So when are we going to be using this templates for functions is appropriate when you have multiple functions that they have or perform the same task, but they have different data type, as we have been mentioning. And you can be so you're going to be converting that into a template. We will be using the template prefix if that's the case, if that's what you feel that your program maybe, it's better to go and do the templates for the function instead of like just declaring functions over and over or repeating your code in a way, like instead of doing function overloading, function templates is the way to go. We do have another, templates that we can use is called class templates. So you can create templates for classes as well. For classes, it is used usually when you have the two classes. So functions, they have the same task, they run the same task, but the class template will be instantiated by, like if you have um, like if you consider these two classes that you have here, they have the same name. But if their member functions or member member variables or data are different, that's where you're going to, or you want to be having or creating a class template. So as you can see, these classes, both of them have the same name, right? This one will be joining two strings or concatenating them, and this one will be by adding, by adding two integers, is just going to return the sum. So as you can see, like it's the difference of the functions, member functions and member variables. So by just writing the same, following the same thing, like if you have the prefix of template keyword and then angle brackets inside that, you put the class and, then the type, which is T stands for that. And you just come up with your class declaration again. And you just come up with the, you have to use that template just like the way you were doing for your function template. Let me show you how this code actually works. Okay, so this is a template class that I was just referring to. As you saw that both of the classes, they were adding or concatenating. So their member function, one of them was returning a string, the other one was returning an integer. That's a very simple, class, and it's called class joiner. So you come up with the template and inside angle bracket again, class T. Now, both of them are actually going to be returning a T, but this T is going to be replaced later on once you create objects from the class. So one of your objects, it could be double, or the other one could be a string, right? Now, you see that in both of these cases, when you call the objects, you have the objects for a string or double or integer, it doesn't matter. For both of them, you're returning specifically the data type, because T is going to be replaced straight on. If it's a string, it's going to return a string. And, you're passing two strings, X and Y. And if it's a string, it's going to be concatenating them. If it's an integer or it's a double, it's going to be adding those values and returning a double value to where they were called. Now, in your main, we're creating two objects from the joiner class. One of them is a type double and the other one is a string. But you see that I have them inside the angle bracket. It's a bit different from the way we were doing the function templates, right? And so I created, these are the types, the data types, and the objects are JD and SD. JD, maybe joining double, stands for that, and SD stands for a string double. So you're going to, so it was better to actually, if they had it as maybe S or JS. So the whole idea is that when you run this code, when you're passing double values, it's going to just add them up and return the sum of them, or summing up these numbers. And if it's a string, both of them, when you pass them, these two arguments is going to just concatenate them and return them. as you can see, this is easy as that, right? 8 and then high hole with a little bit of a space because the space was created here. Okay, so this was the idea of, creating templates for functions and classes. You could use this idea for inheritance as well, classes with inheritance. As you can see in some of this, the class templates could be used in inheritance. And there are some, then, it gets to STL or a standard template library, which I mentioned that I'm going to have that as a separate video for you guys. See you guys in the next video. And hopefully I will be posting projects and programs program assignments that you need to do for chapter 16 by tonight. Have a great Thanksgiving. Bye-bye.